Hello, my name is Kaan Berkay Gürkan. Today I will present my Tetris project. Let's explain the Tetris game. In Tetris, players complete lines by moving different shapes, which descend onto the playing field. The completed lines disappear, collapses, and grant the player points. If block reaches the top of the game board, game ends. Let's start the explaining the code. This is the initialization phase. Stage, block, and field are 4x4 two-dimensional vectors. They keep the data of the game board. In the beginning, all of them are set to 0. X and Y are the starting coordinates of the game board. In the beginning, game over condition is set to 0. This data type is either 1 or 0. Game speed decides the speed of the game. Borders and Tetris shape decides shapes. Score is set to 0 in the beginning. Block list keep all the tetromino shapes. So here is the function for the Tetris game. I will explain them in the code blocks. Since there are nearly 20 functions, it is best to separate them into the 3 different parts: game design and menus, game logic and mechanics, gameplay and control design. First one is about interface of the game. Let's begin to explain the codes briefly. Title function clears screen and prints menu display. Displays menu and provides valid controls for menu. Lets player decide whether he wants to back to the main menu. Lets player decide the difficulty level of the game. Informs player game is over. This part of the function displays the game and includes various game mechanics. Displays the game board with the help of the field vector. Decides if the moving tetromino collides. Allows that collapsed blocks are also a collision condition. This is the elimination mechanic. Creates a new tetromino. So if the tetromino collapses, this function prepares the next block and launches it. Let's start. Visualize the Tetris game board with boundaries and blank space. Game progress. As long as game is not over, game proceeds. In the last part, functions provide controls. Decides what user input will do in the game. Rotates block 19-degree clockwise. Rotates block 19-degree anti-clockwise. Block is shifted by x2 and y2. And this is the main function. It lets user play the game. Now let's explain the algorithm with flowcharts. We are in the game loop, and as long as time doesn't exceed the game speed, it increases. After it exceeds the game speed, we are in the span block. If block is not collided in the next y coordinate, it moves the block to there. If it is collided, then execute the following conditions. Check eliminate row, check collidable, and make blocks. If block is occupied in the top of the game board, game ends. If it is not, game loop continues. So this is the gameplay and control design flowchart. You start here, you give an input, and by this input, algorithm decides what code will be executed. Now we are on the menu diagram. So we are in the menu. If we press 1, game starts and continues. If it's game over, you direct to the menu. If you press 3, you change the difficulty and again back to the menu and press for game ends. Now let's play and control the game. First of all, I want to start a new game. By pressing 1 and enter, I start a new game. By pressing A, I move to the block to the left. By pressing D, I move the block to the right. By pressing down arrow key, I drop the block immediately. So by pressing right arrow, I rotate it clockwise. By pressing left arrow key, I rotate it anti-clockwise. So let's make a row and check if the row collapses. As you can see, the row is collapsed and our score is increased. Let's go to the back to the main menu. Let's load the game again. Let's go back again. I want to change the difficulty options. I choose the hard mode and start a new game. As you can see, the pieces will be dropped faster. So let's make the game over. So game over is prompted to the player and score is displayed. And if I press a button, then I will be on the menu. Thanks for watching.